Have you ever held an opal and wondered how nature creates such mesmerizing rainbows trapped in stone? Today, we're diving deep into one of geology's most beautiful mysteries, the incredible formation of opals, from ancient volcanic landscapes to microscopic spherical structures. Prepare to discover the fascinating science behind these dazzling gemstones. Our story begins millions of years ago, when ancient Australia was a very different place. Massive volcanic eruptions covered the landscape, creating layers of rock rich in silica, the key ingredient for opal formation. But opals aren't born from fire alone, as these volcanic rocks weathered over countless millennia. Rain and groundwater slowly dissolved the silica, creating a silica-rich solution that seeped through cracks and cavities in the rock. The Australian outback, particularly the famous Lightning Ridge and Cooper Pedy regions, became nature's laboratory for opal creation. These areas had the perfect combination: silica-rich bedrock, arid climate, and just the right geological conditions. What makes this process truly remarkable is the time scale. We're talking about 5 to 30 million years of patient geological work. Each opal deposit tells a story of ancient climates, vanished seas, and the slow but persistent power of water. Now, here's where the magic truly happens. As the silica-rich water slowly evaporated, it left behind tiny spheres of silica, each about 150 to 300 nanometers in diameter. That is about 300 times smaller than the width of a human hair. These microscopic spheres arrange themselves in incredibly ordered patterns, creating what scientists call a photonic crystal. When white light hits these perfectly organized spheres, something extraordinary occurs. The light is diffracted and broken into its component colors, creating the stunning play of color we see in precious opals. Different sphere sizes create different colors. Smaller spheres produce blues and greens, while larger spheres create reds and oranges. The most valuable opals contain spheres of varying sizes, creating a full spectrum of colors that dance and shift as you move the stone. But not all opals display this rainbow effect. Common opals, also called podge, have irregularly sized spheres that don't create this optical phenomenon. They're still beautiful, but they lack the mesmerizing color play that makes precious opals so coveted. Throughout history, opals have captivated civilizations across the globe. Ancient Romans believed opals contained the beauty of all gemstones, while Aboriginal Australians have creation stories where the rainbow serpent nests journey across them, land left behind these colorful stones. Today's opal market is fascinating and complex. A single high-quality black opal can sell for tens of thousands of dollars per carat, making it more valuable than diamonds. The value depends on several factors: the intensity and variety of colors, the pattern of the color play, the clarity of the stone, and its overall size. But opals aren't just pretty faces in the jewelry world. Their unique optical properties make them valuable in scientific applications. Researchers study synthetic opals to develop new optical materials and photonic devices. Some scientists even use opal S structure as inspiration for creating materials that could revolutionize solar panels and LED technology. The hardness of opal, ranging from 5.5 to 6.5 on the Mohs scale, makes it softer than quartz but harder than glass. This property, combined with its water content of 3 to 21%, means opals require special care and can be sensitive to temperature changes. Opal research continues to surprise us with new discoveries. Recent studies using advanced electron microscopy have revealed that some opals contain incredibly complex nanostructures that we are still trying to understand. Scientists have discovered that the formation process is even more intricate than we initially thought. One groundbreaking discovery involves the role of bacteria in opal formation. Some researchers believe that certain microorganisms might actually influence how silica spheres organize themselves, potentially explaining why some opals have such perfect structural arrangements. Mining technology has also evolved dramatically. Modern opal mining combines traditional techniques with advanced ground-penetrating radar and 3D mapping to locate deposits more efficiently while minimizing environmental impact. sustainable mining practices are becoming increasingly important as we work to preserve these geological treasures for future generations. Perhaps most exciting are the recent discoveries of opal on Mars. NASA's rovers have found opal deposits on the red planet, giving us clues about ancient water activity and potentially even past life on Mars. As we conclude our journey into the world of opals, it's important to remember that each stone represents millions of years of Earth's history. Every flash of color, every play of light tells a story of ancient environments, patient geological processes, and the incredible creativity of nature. The next time you see an opal, whether in a museum, jewelry store, or perhaps in your own collection, take a moment to appreciate the extraordinary science behind its beauty. Remember that you're looking at a perfectly organized array of silica spheres, each positioned with nanometer precision to create that breathtaking display of colors. Opals remind us that some of nature's most beautiful creations require immense patience and the perfect combination of conditions. They're not just gemstones, they're windows into deep time, evidence of our planet's dynamic history, and inspiration for future scientific discoveries. Thank you for joining me on this geological adventure. If you enjoyed uncovering the mysteries of opal formation, be sure to subscribe for more fascinating explorations into the natural world. What other geological wonders would you like to explore? Let me know in the comments below.